Hello, and welcome to Xamarin University. My name is Adrian Stevens, and thank you for joining me for this video presentation of IOS205. And in this class, we're going to explore navigation patterns in iOS. Before we get started, please make sure you've downloaded the class materials from university.xamarin.com and make sure that your build environment is set up to compile and run iOS applications. When we create mobile applications, we want to arrange the user interface in ways that will seem natural and intuitive to the end user. And just as importantly, in a way that allows them to successfully navigate through all of the content within our applications. So today, we're going to look at several navigation metaphors used on iOS that can be used to display and organize multiple pages of content. We'll not only look at how to use these navigation patterns, but also discuss when to use them as well. We'll begin by exploring what's probably the most common pattern on all mobile devices, and that's stack navigation. And stack navigation provides the standard forwards and backwards navigation within an application. We'll then look at using tabs for navigating our application content. And tab navigation is very often used when you have only a few related screens to switch between. Then we'll move on to master detail. And master detail navigation UI is separated into two sections. The master section providing a list of selections, and when a selection is made, the detail section provides the content, or details for a given selection. We'll wrap things up today with a short discussion with a fourth pattern, page navigation. Now let's start by exploring stack navigation on iOS. And in this section, we'll see how to implement stack navigation both programmatically and using the iOS designer. As mentioned, stack navigation is probably the most common navigation pattern used on mobile. And that's not only for iOS, but also on Android and Windows Phone. And even if you haven't called it by this name, I'm sure you've implemented this pattern at some point in your applications. Now with stack navigation, the user starts at a screen, and they'll make a selection, and that will cause navigation to a new screen. Some form of back button will be provided to return to the previous choice, and as you progress forward, the previous screens are held in a stack. Now, stack navigation systems can be found in menu structures and data tree presentations, and a great example, as we can see here, is the iOS Settings app. And the term stack navigation says a lot about how this navigation pattern works. New screens, or more specifically in iOS, new view controllers, are added to a stack of, view controllers. And the last item added to the stack is on top, and it's the only visible screen or view controller. And so using this form of navigation, only one screen is ever visible at one time. In iOS, the UI Navigation Controller class provides this basic stack navigation. The UI Navigation Controller is a UI View Controller derived class that holds other child view controllers within a stack. After providing an initial view to present, subsequent clicks or interactions can cause new views to be pushed onto the navigation controller to be presented on screen. And you can continue to push as many new view controllers onto the stack as you'd like to drill deeper into the relationships between your data. It also provides the UI needed to go backwards in the stack. And this is referred to as the navigation bar and provides space for a title as well as a back button when more than one view controller is on the stack. We can create a UI navigation controller either programmatically or in a storyboard using the designer. And when working with navigation controllers in code, we'll often set the navigation controller as the root view controller of the UI window. And this is often done in our finish launching override in the app delegate just before presenting the initial UI. Now we can optionally set the initially displayed view controller by passing it into the constructor, and if no other view controllers are added to the stack, this child view controller will be visible. Now once the navigation controller has been instantiated, we can add additional child view controllers to the stack by calling the push view controller method and providing a new child view controller. And as you can see, the push view controller method is defined on the UI navigation controller class. Now, as a convenience, we can access a navigation controller from a property defined on these child view controllers. Every UI view controller derived class has a property called navigation controller. And when a view controller has been added to a UI navigation controller, this property will give us direct access to the parent navigation controller. And this saves us from needing to pass references of the navigation controller around within our application. This property is primarily used to instantiate navigation, most often by pushing new child view controllers onto the stack. Now, the navigation controller property is present on all view controllers, but it will be null if the view controller is not contained within a navigation controller. Now, when we want to return back to previous screens, we call this back navigation, and it's simply the act of navigating backwards through the stack. Back navigation can be accomplished via the provided back button, and that will automatically appear on the left side of the navigation bar. It can also be done programmatically, and on iOS 7 and up, we can swipe from left to right across the screen to instantiate back navigation. This is assuming, of course, that the UI on screen is not intercepting touch interactions. Now, when back navigation occurs, the top view controller is removed from the stack, and then the next item below on the stack becomes visible. And of course, it's not possible to pop or remove the root view controller, i.e. it's not possible to fully empty the stack. Now, to navigate backwards programmatically, we can use the pop view controller method on a UI navigation controller. And it's very similar to push view controller, except we don't need to provide a reference to the top screen. You can also use the pop to root view controller method, and that will return to the root or the first screen. And this will remove all other child view controllers from the stack. There are a few other properties and methods which can be used to manipulate the navigation stack. You can always reach the root or the first view controller through the top view controller property, and the currently visible controller can be reached through the visible view controller property. Now, the actual stack is managed as an array of view controllers, and that's reachable through the view controllers property. And you can check this array to see what's on the navigation stack, and there must always be at least one view controller present for it to be valid. And there are methods to directly work with the stack. You can pop off several view controllers with pop to view controller, or as mentioned on the previous slide, go back to the root using the pop to root view controller method. And these two methods are useful if you find yourself deep in your navigation and you want to return to a specific screen or start over. And you can actually completely replace the navigation stack with a predetermined set of view controllers by either changing the array directly or calling set view controllers, which allows for animations. And you might do this to restore the application to a known state, or after a restart, or just to launch the app at a known screen based on some sort of flag or input from a service. Now I'd like to show you an example of implementing stack navigation programmatically. Here I've opened Xamarin Studio, and I'll make a new iOS project. And I'll use the empty project template. We'll give our project a name. And create. And as soon as this is ready, I want to open up the app delegate. And let's do a little bit of work in our finish launching override. So let's first create a new UI navigation controller. I'll call it nav controller. And I'm going to set this as the root of our UI window. And let's run this and see what it looks like. Remember, of course, the navigation controller is designed to show child view controllers in the stack. Now, of course, we haven't added anything to the stack yet, so this is the default visualization, and there's not much here. The light gray bar up top represents the navigation bar, and then the black area is to show the content or the child view controllers. So let's give it some content. I'm going to create two UI view controller derived classes. Let's make a yellow view controller and an orange view controller. Now both classes need to, of course, derive from UI view controller, and we'll need to resolve at the using UI kit. I'll do this for orange as well. And in both view controllers, I want to do a couple of things. I'm going to set the background color, and we'll set them to match their name, UI color yellow. I'm also going to set the title property of the view controller. We'll just call this yellow. And let's duplicate this for our orange view controller while we think about it. I'll get that missing quote. Now we'll use our new view controllers. I'm going to start by showing the yellow view controller as the root of our navigation controller. So we'll make another local variable. Let's call this yellow view controller and new up a, well, yellow view controller. Now we'll pass this in to the constructor of our navigation controller, and this will set it as the root view controller. Let's run our application again and take a look. Now there's a few interesting things here. One, we see our yellow background, of course, so we can see that it is displaying our child yellow view controller. It's also reading the title property and displaying that in the navigation bar. But notice the color of the navigation bar. It's a muted yellow. And that's because the navigation bar on iOS 7 and up is semi-transparent, and so it lets that yellow background color come partially through. And that's just part of the visual styling, the new iOS appearance that came in with iOS 7. So now let's wire up some navigation. And we'll do this from our yellow view controller. To do this, I'm going to make a button. And I'll use the from type factory method. And I can use that default but old naming convention rounded rect, and that's really just the default button style. Let's also set a title, and let's just call this go to orange. And when we set the title on our button, we'd set the UI control state. And if we set the normal control state, that will set all other control states, so we'll always see a title on our button. Let's also size and position our button. We'll do that using the frame property. I can new up a new CG rect. I'll set this as 0, 0 for now. We'll give it a width of about 100 and a height of 30. And then a little bit of trickery or laziness efficiency, I'm going to set the center of our button to the center of our view controller, or of the view on the view controller, and that'll just center our button on screen. But for this to work, we have to, of course, add it to our view controller. Now, what I really want to do is respond to button clicks and navigate to our orange view controller. So the simple button click event is touch up inside. That's our event handler. And let's just do a quick lambda expression. Now we're going to use the navigation controller property, and this is defined on UI view controller. Now remember, this will only be wired up. This will only be connected to our parent navigation controller if we are contained within a navigation controller. Otherwise, this property will be null. Now we did add our yellow view controller to a navigation controller in the app delegate, so I'm confident that this is wired up. And I'm going to use the push view controller method. This takes two properties. The first is a view controller, so let's new up our orange view controller. And the second is a boolean stating whether we want to see an animation when it scrolls on screen. I like the animation, so we'll set that to true. Let's go ahead and run the project. And perfect, we see our go to orange button centered on screen. Let's click that button. We see a pan animation with our orange view controller coming on screen, and a couple of interesting things to note. Of course, again, we see our orange background and we see the transparency on the navigation bar. We also see the title property being respected for the currently displayed view controller. And finally, we see the title for the previous view controller. Now, this won't always show. The title must be short enough to fit on the button, but if it is, you'll see it. If your title is longer for the previous view controller or it's not set, that will simply say back. Of course, assuming that your region, your language is set to English. And as you can see, it's fairly easy and fairly straightforward to implement basic stack navigation programmatically in iOS. Now, much like the navigation controller property we talked about earlier, every view controller also has a navigation item property. And we use the navigation item property to customize the appearance and the behavior of the navigation bar when a given view controller is visible on the stack. Or, to describe it another way, the UI navigation controller will look for the navigation item property when a view controller is being displayed and use it to configure its navigation bar. And with it, we can set the displayed title, add a prompt, or even add buttons to the navigation bar. Now, to add buttons, we create UIBarButtonItem objects. And these can be added to the right or left sides of the title. And these UIBarButtonItems can contain plain text, images, or even custom views. And that means we can place almost anything within reason on the navigation bar. Although it's typically just simple image-based buttons, and according to Apple's guidelines, the images should be 22 by 22 points, and of course don't forget to supply the @2x and @3x resolution resources for Retina and HD displays. In addition, when supplying images, the system will recolor them to match the system-defined colors, known as templating. The alpha values in the source image are actually used to create the images, and any opaque values are ignored. Now we'll use three properties defined on the UI navigation item object to set buttons on the navigation bar. Now left bar button item can be used to add a button to the left side of the title. Now this is not commonly used except for screens set as the root, and this is because it will hide the default back button, potentially blocking navigation to previous screens. The most commonly used property is WriteBarButtonItem. And this allows you to add a button for additional information and functionality without impacting navigation. And you can also customize the button that will return to the current screen or view controller. So this is the button that will be displayed when you need to navigate back to this current screen, i.e. after forward navigation occurs. And this is useful if you don't want the back button to show the title of the view controller, commonly replaced with an image. And finally, there are plural forms of the left and right properties which take an array of buttons. And this allows you to set multiple buttons into the navigation bar, and they're displayed right to left based on the order in the array. Now, the number of buttons displayed depends on the form factor of the device and the orientation, but typically you can fit at least 2 on either side. Now, the navigation item property makes it easy to programmatically add buttons by simply instantiating a UIBarButtonItem and assigning it to the appropriate property. And the UIBarButtonItem constructor has several overloads, making it easy to create bar button items with text, with images, or custom views. Now, new in iOS 8, we also can take control over showing the navigation bar. So we can hide the navigation bar by setting properties directly on the instance of the UI navigation controller. You can now hide it on swipe, on tap, when the keyboard appears, when on an iPhone in landscape orientation, or when the view is pushed onto the navigation stack. And this is done simply by setting the appropriate Boolean property. And this allows you to make better use of the available screen space and is particularly valuable on smaller devices like the iPhone. And we're not limited to implementing stack navigation programmatically. The Xamarin iOS Designer has excellent support for adding a UI navigation controller to a storyboard. Using the toolbar, you'll search for Navigation Controller and then drag it onto your design surface. And when it's created, the navigation controller will include one child view controller, which will be set as the root, and you can use that or you can remove it and replace it with another view controller within your storyboard. Now, typically, we use a push segue to add new view controllers onto the stack. And this is done by control dragging from a clickable UI, such as a button, to the new view controller. Now, new in iOS 8 is the show segue. And we'll talk a bit more about this later, but for the purposes of stack navigation, the behavior of the push and show segues are the same. And it's recommended to use push if you're supporting older versions of iOS, otherwise use the new show segue. We can interact with the view controller that's going to be shown via segue by overriding the prepare for segue method on the source or parent view controller. And this gives us an opportunity to call methods or interact with public properties on the view controller before it's displayed. A great way to pass in data if needed. Now, there are also situations where it can be difficult to use a segue for navigation. As an example, when clicking on a dynamically populated table view. And in those cases, we can instantiate a view controller programmatically and again use that push view controller method. Now, to create a view controller that's been defined in a storyboard, we use the instantiate view controller method, passing in the storyboard ID of the new view controller, but notice it's passed in as a string. And a quick word of warning, make sure not to make any typos, or you'll get null instead of your new view controller. You'll also want to cast the returning view controller to any custom view controllers you've implemented, which will allow you to access specific properties before displaying it. And we often do this, for example, to initialize a detail screen before pushing it onto the navigation stack. It's now time for your first individual exercise, where you'll have the opportunity to implement stack navigation using the Xamarin iOS Designer. please now go to your downloaded course materials for iOS 205 and open up the Start Here HTML. This file provides an overview for the class we're working through today. It also includes a link under Lecture to a PDF version of the slides that I'm using to present, and these are an excellent resource for you to use after class, to review content, or to study for the certification exam. It also includes detailed exercise instructions for all 3 of the exercises we're going to complete today. Please open up the instructions for exercise number 1, stack navigation. Now this should take you approximately 20 minutes, and you're going to start with an existing Xamarin iOS project. And in this project, there are several pre-created view controllers. They've been defined using a storyboard. You're going to add a UI navigation controller and wire up basic navigation to all the different sections of the application. Now please pause the video and begin exercise number 1, and when you're ready to review, you can resume the video. Let's now review exercise number 1. I've opened the starter solution from the Part 1 resources folder, and here we see our main storyboard. Our project already has 4 view controllers defined. We have one for our clock, a second as a stopwatch. We have a third view controller, which is going to be used to display split or lap times, and an about screen. But there's no navigation created yet. In fact, the only view that's visible, the only view controller that will currently be visible or accessible is our clock view controller, because the sourceless segue is pointing to it. And if we run our application now, we'll see our clock screen, but there's no additional UI to access the rest of our content. So let's fix that. And we'll use a UI navigation controller, of course. So from the toolbox, I'll search for navigation controller. You can see we don't even need a complete search term. And we'll bring this on to our design surface. As discussed earlier, by default, the navigation controller includes one child view controller set as the root, and that's so it has some content to display when it initially appears. And we're not going to use this root view controller. We're going to create our own. So I'm going to click on the gray bar, press the delete key to remove it, and we see our segue disappears with it. Let's search for a table view controller. And we'll use this as a menu of sorts to access the rest of our content. Now I first want to set our table view controller as the root child in our stack. So to do this, I'm going to hit the control key and hold it down. I'm going to control drag from the navigation controller to the table view. When I let go, we get a context menu, and I can set the relationship as root. This creates our segue. And now when the navigation controller is displayed, our table view will be the first view on the stack. The next thing I want to do is make sure that our navigation controller is the first thing we see when our application is loaded. And so to do this, I'll move the sourceless segue and just have this point to our navigation controller. Next, let's do a little bit of work to set up our table view. Start by clicking on the prototype cell. That's that empty white rectangle. And when it's selected, you'll see the class is grayed out, but it says UI table view cell. We'll change the style to basic. We're only going to display a single line of text, so that is perfect. And we're going to use it for navigation. So I want to change the accessory to disclosure indicator, and that's that little chevron. That's commonly used to indicate navigation, and we should use that here. I also want to set the reuse identifier, and that's in the identifier field, and we'll set that to simply cell ID, no spaces, all lowercase. And this is going to match some code behind logic we have already. We'll also set the title for our table view controller. I can simply select the title and then change it in the navigation item section. I'll call this clock menu. Next, I want to bring in some existing code, and this is just providing code behind logic for a table view controller, and very similar to the content you covered in iOS 110 and iOS 115. Go to your downloaded course materials and navigate to the infrastructure folder in the Part 1 resources, and bring these two files into your project. And of course, we'll copy those. And we'll use this for our backing class for our table view controller. Now, to connect our UI to this backing class, we simply need to populate the class field. So with the table view controller, make sure under identity, the class says UI table view controller. We're going to set this to match the file we just brought in, or files, I should say. Menu table view controller. And this is now going to associate this class with our UI element. And if we hadn't already brought these files in, if they hadn't been created, then the designer would automatically create empty classes for us. And you can see here we have a table view controller and a controller.designer file. Let's open up our menu table view controller. Please feel free to pause the video and inspect. It's a simple table view controller implementation along with a table view source. This is all wired up. And this code has been set up to display a simple array of strings, one for each section in our application, our clock, our stopwatch, and our about screen. And if we run our application now, we should see our 3 entries in the table view. And there we are, we see our text and our chevron, but there's no navigation. So let's wire that up. Now there are many ways we could do this, and we didn't need to use a table view controller. We could have optionally put buttons on a simple view controller and use segues via the control drag to navigate to our sections. But in this case, we'll use a table view. And this is a very common approach. And when using a table view, you'll often implement navigation programmatically, and this allows you to make decisions on where to navigate based on selection, based on your content. So in our code behind, in our menu table view controller.cs file, go to the table view source class and scroll down to the row selected method. And just a reminder, this is the method that's called whenever you click on a row within your table view. Now I'm going to copy paste this code from the lab instructions. And what we have is a switch statement based on the row selected, the row clicked. We use the NS index path property, and use the row property on that. Of course, this is 0 index. The first is our clock screen, second is our stopwatch, and finally our about screen. Now, remember, we want to navigate to a view controller. We use our push view controller method. This is defined on a UI navigation controller. We're going to use that convenience property called navigation controller, and this is defined on our table view controller. And if you browse the code, you'll see that we've passed in a reference to our table view controller in the constructor of our table view source. And again, there's more than one way to wire this up. This is how we've implemented it for this particular exercise. Now we need to specify the view controller that we're navigating to in our push view controller method call. And to do this, we're going to load in or instantiate the view controllers that have been defined in our storyboard. And to do that, we'll use the instantiate view controller method. Now it's very important to make sure that your string is exact. It is a string, and this is the name of the view controllers as defined in the storyboard. So if this doesn't match perfectly, you're going to get a null view controller back and your navigation is going to fail. So for example, here we see clock view controller. If we go to our main storyboard, you can see the storyboard ID has been set to clock view controller. And it's not uncommon to use the same value for the storyboard ID and the class. It is absolutely acceptable. But just note, this is the storyboard ID that needs to be set here, and it must be exactly as it is in the storyboard, and it is case sensitive. So again, we instantiate and we push. Let's see what this looks like. Here's our menu, our table view controller, and click on clock, and again we see our clock screen. And now we see that automatically provided back button from our navigation controller. I'll return back. We can go to our stopwatch, and of course we can start and interact with it. Now notice that we do have a view splits button, and this hasn't been wired up yet. Now we have a few options for doing this. We could do it programmatically, or we could do it from the storyboard. So let's go to the storyboard and wire up our split, our lap time view controller. I can do this by control dragging from the view splits button to our lap times table view controller, and I'll set the segue action to push. And let's launch our application again. We'll run our stopwatch. We'll push our view splits button, and now it navigates to the new screen, and again we see the back button provided. However, we haven't implemented any logic to populate the lap times. Now there's, again, more than one way you can accomplish this. Please feel free to pause the video, try and think of how you might want to pass in the data to the lap times table view controller, and there is an example in the completed folder, in your part 1 resources folder. And there we've seen stack navigation using the storyboard designer. Again, we added a navigation controller, set our root view controller. We instantiated navigation to our 3 main sections programmatically, and then also used a push segue to connect to our lap times. In this section, we learn how to implement stack navigation, both programmatically and using the Xamarin iOS designer. We also saw how to customize the appearance and behavior of the navigation bar for each child view controller contained within the stack. Next, we'll take a look at organizing our UI using tabs in iOS. Like stack navigation, iOS has a special type of view controller that we can use for tab navigation. We'll see how to create the tab infrastructure, display text and images on each tab, and connect child view controllers to be displayed within each section of the tab view controller. Now, like stack navigation, tab navigation is quite common on mobile platforms, and iOS is no exception. Users can choose between different functions or screens within an application by selecting or clicking on a tab. The current tab is then highlighted, giving context to what the user is viewing. And some examples of this navigation pattern include the default iOS clock app, the iOS App Store, as you can see on screen, and even the current Twitter application is using tabs. And basic tab navigation in iOS is done using the UI TabBar controller class. Tabs are displayed at the bottom of the screen, and each tab hosts its own view controller. And a tab can even host a UI navigation controller, and this allows for stack navigation within any of the tabs. And this is a great option for navigation when you have 3 to 5 distinct sections for your content. To control the appearance of the tab, we use a UI TabBar item. And the TabBar item serves a similar purpose in tab navigation as the navigation item did for stack navigation. And we use the UI TabBar item to set the image and the text for a given tab. Now, every view controller has a TabBar item property that can be assigned to an instance of a UI TabBar item. And when the view controller is displayed within a UI TabBar controller, its tab will be visualized using the properties of that selected TabBar item. So let's look at an example of using a TabBar controller programmatically. We'll start by subclassing UI TabBar controller. Next, we'll define the contents of each tab. And again, remember each tab will host its own view controller. So we'll create one view controller for each tab. And these view controllers will determine the content that is shown on screen when a tab is selected, and will set the TabBar item property. And as you can see here, we can simply new up a UI TabBar item specifying the tab's title and image. Now, once the child view controllers are created, we assign them to the TabBar controller through the view controllers property, as you can see at the bottom of the screen. This accepts an array of UI view controllers, one for each tab, and the order that tabs are added to the array will be the order that they're shown in the TabBar. When adding images, we can display custom images, which will be added to our project as resources. The minimum size is 25 by 25 points, and the maximum size is 48 points wide and 32 high. Generally considered best practice to use 32 by 32 point PNG images. And again, of course, be sure to include the Retina, the at2x, and the HD at3x versions for higher resolution devices. There is also a small selection of system-provided images available, and to use these images, we'll use an overload of the UI TabBar item constructor, passing in a UI TabBar system item enumeration. And there's several to choose from. You can see some examples on screen: more, favorites, featured, top rated, etc. Now, it is important to note, if you use the system provided images, it will also automatically set the text on the tab, and it's not possible to override this provided text. You can also assign this value in the iOS designer when building your tabs, and we'll talk about that in just a moment. Now, the TabBar has a limited amount of space, and with that, it can only show a limited number of tabs. And if you exceed it, it's going to automatically show an overflow icon in the rightmost tab position. Now, this overflow icon will give access to any additional children. And when clicking, a table view will be displayed, showing those additional entries by name. Now, all iPhones allow for 5 tabs, with one exception. The iPhone 6 Plus, when in landscape, allows for 8 tabs. When using the tab view controller on iPads, in either orientation, the iPad allows for 8 tabs. Now, for those of you familiar with reactive UI strategies in iOS, this is due to the vertical size class. And when the size class is compact, it allows for 5 tabs. The regular size class allows for 8. And the system automatically transitions between the views when you activate a tab. But you can provide your own logic as well. So if you need to detect when a tab is selected, you can subscribe to the View Controller Selected Event Handler on the UI TabBar controller class. Now, the event handler passes a UI TabBar selection event args, which contains one important property: selected item. And the selected item is a reference to the child view controller for that tab. Now note, there is no index for the selected tab, so if you need to determine which tab has been pressed, you may need to provide some additional logic. You could do things like compare the titles, or if you're using a custom base class for your view controllers, you could add an index property. We can also display a small amount of text as badges on a tab. This is done by setting the badge value property on the UI TabBar item. Generally speaking, badge text should be no more than 2 or 3 characters, and it's most commonly used to display a numerical value, very often indicating a number of new things or a number of updates. And this is a great example. The iOS App Store will give us a numerical value showing how many new updated apps are available. If you need to clear the badge value, simply set it to null. Now, just like the navigation controller, we can add a UI TabBar controller using the iOS designer. You'll use the toolbox and search for TabBar controller. And when added, it comes along with 2 additional simple child view controllers, and these are wired up to 2 tabs. And you can, of course, remove these 2 view controllers, or you can add additional view controllers, and we do this by control dragging from the UI TabBar controller to another view controller, and then set the segue relationship to tab. Now, once a view controller is connected via a segue in the designer, it's very easy to customize the tab's text and images using the Properties pane. From here, you can set the tab's title, set an image, or as mentioned earlier, we can set it to use a UI TabBar system item. And as you can see on screen, you'll get a preview of the tab, and that will be displayed at the bottom of that connected view controller within the storyboard. So it's time now to try this out in your second exercise. And you're going to use a similar starter project to exercise number 1, but this time you're going to arrange the content using a UI TabBar controller. So please return to your downloaded course materials and open up the instructions for exercise number 2. And again, this should take you approximately 15 minutes. So please pause the video, work through the steps, and resume when you're ready to review. Let's now review exercise number 2. Here I've opened the Start solution in our Part 2 Resources folder. And in our main storyboard, we see again, we have 4 view controllers created for the various sections of our application. And again, only the clock will be visible via the sourceless segue. So let's add some tab navigation. Scroll out. I'm going to search for TabBar controller in the toolbox and drag this onto our design surface. And we see it takes up quite a bit of space. It's added our TabBar controller along with 2 wired child view controllers wired up via tabs. We're not going to use these because of course we'll use the sections of our application, so we can delete them by clicking on the gray portion below the view controller and pressing the delete key. And that removes the segues as well. Now let's connect our first view controller to our TabBar controller. I'm going to again control drag to our clock view controller, and the context menu will allow me to set the relationship to tab. And this does a couple of things. It of course creates our segue. It also now shows a preview of the tab for our clock view controller at the bottom. You can see there's no image yet, and it's using the default text item. It also appears on the TabBar controller, which currently only has 1 tab. So let's wire up a second. Again, I'll control drag to our stopwatch, set the relationship to tab, and now we see there are 2 tab items on our TabBar controller. And let's do this again for our About screen. We won't connect our lap times view controller as a tab, because we'll of course launch that from our View Splits button on the stopwatch. And we see we actually have 3 tabs added. They're a little bit plain, but this should already work, even in its default form. So let's run the application and try it out. Of course, I forgot one important step. Let's fix that now. I forgot to move the sourceless segue from our clock down to our TabBar controller. Of course, we want the TabBar controller to be responsible for presenting the initial UI. So we'll run this again. And now we again see our clock screen, but now we see our tabs at the bottom. They're not very descriptive with that default item text, but we can see the first one is selected in blue. And if I click on the second item, this now shows our stopwatch, and we can go to the third one for our About screen, with the current tab being highlighted in blue. But let's make this a little bit more interesting. Let's add some images and some more descriptive text. So we can use PNG assets for the tabs. And it turns out we've included some in our downloaded course materials. So if you open up your Part 2 resources folder and then open up infrastructure, you'll see several PNG images. I want you to drag these into the resources folder. And we see we have 3 about icon PNGs, 3 for clock, and 3 for stopwatch. 3 because we have 1 for each pixel density on iOS. We have regular, Retina, and HD. So let's put these to use. To do this, we can go to each view controller, click on that tab preview, and in the properties pane, we can edit the title. Let's call this clock, and set an image. And in our case, we'll use the clock icon PNG. And this will automatically use the higher resolution versions of the assets on high resolution devices. And there we see our lovely clock PNG image. We'll do the same for our stopwatch, setting the appropriate PNG, and our About screen. Now notice, I'll scroll over to our TabBar controller. We also see the preview here as well, giving us a great idea of what this is going to look like when we run the application. And that looks a whole lot better. We see our icons, and we have far more descriptive text. And again, notice as we change sections, both the icon and the text get highlighted in blue. This is because iOS applies what they call templating. And so it applies this consistent visual styling to the assets. So we see that our icons are highlighted in blue and our text as well. Our icons are not necessarily set to gray, they're actually black and white, but iOS applies this templating to give it that consistent look and feel. Now, as a bonus exercise, think of a way to wire up our lap times, our splits view controller. In the last exercise, we talked about just pushing it onto the stack, but this time we're not using a navigation controller, so that's not an option. You may want to pause the video, think of a way you can accomplish this, and then please take a look at the completed solution in the Part 2 resources folder. It has one possible solution. In this section, we learned how to use the UI TabBar controller, both programmatically and using the Xamarin iOS Designer. And we also discussed how to control the appearance of the tabs by setting the TabBar item property on the child view controllers. Our third navigation pattern is called Master Detail. And for Master Detail navigation, we'll use another built-in iOS controller, the Split View controller. In Master Detail navigation, the UI displays a master list of items, typically on the left, along with the details for the currently selected item on the right side of the screen. And this pattern works very well for applications that need to provide quick access to details, especially for larger data collections. And contact applications are a great example of this. So you might see a list of contacts on the left side of the screen, and then details for a currently selected item on the right. It's also sometimes preferred over stack navigation on devices with larger screens, as it makes better use of the available screen real estate. Now, the UI Split View Controller class is a container view controller that displays two side-by-side sub-view controllers. The left view controller shows a list of selectable items, and the right side displays details for the selected item. But the split view controller has really no significant interface of its own. Its job is to present the two child view controllers. Now, prior to iOS 8, the split view controller was only available for use on iPads. And if you tried to use it in an iOS application, it would throw an exception at runtime. Now, new in iOS 8, we can use the split view controller on all current iOS devices, as long as they're running iOS 8 or newer. Now, when used on the iPhone, the split view controller collapses, and it behaves much like a UI navigation controller. And it will continue to work the same as it always has on the iPad, with no additional code. And that, of course, will then show us both the master and detail views simultaneously on the larger screen. It's important to note, though, although it behaves like a navigation controller on the iPhone, the stack is limited to 2 levels. And like our other patterns, we can instantiate master detail navigation programmatically. And first, we would derive a new class from UI split view controller. And then we need to instantiate 2 child view controllers, one for master and one for detail. And these get assigned to our split view controller through the view controllers property. And this looks a lot like our tab view controller. But in this case, we only assign 2 child views. The first is the master and the second entry is the detail, as you see here on our slide. Now, earlier we talked about the push view controller method, which we use for forward stack navigation. Now, new in iOS 8, we have the show view controller method. And unlike push view controller, which was called from the UI navigation controller, the show view controller method is defined on the view controller class itself, and it has some really interesting abilities. So first, if the view controller that it's called from is contained within a split view controller, the show view controller method will replace the master view controller. However, if the view controller is contained within a navigation controller, then this method will push the new view controller onto the stack. And so this method both replaces and simplifies the push view controller method for stack navigation, and should be preferred if you're supporting iOS 8 and up. Additionally, if the view controller isn't contained within either container, show view controller will present the new view controller modally. And so simply put, it does the correct thing depending on the design of your UI. And we have another new method in iOS 8. And this is the show detail view controller method. And it's primarily intended to update the detail view of a split view controller. And just like show view controller, it's defined on the view controller. And again, if the parent is a navigation controller, then this method also pushes the child onto the navigation stack. And again, doing the right thing based on the current UI configuration. And of course, like our other patterns, we can use the designer to add a UI split view controller. From the toolbox, you'll search for split view controller and drag it onto the storyboard. And when you drag this onto your design surface, it'll create the split view controller, but it includes 3 children. And as a result of this, it takes up quite a bit of space. So I recommend zooming out or panning to an empty section of your storyboard before bringing a new one in. Now, these 3 child view controllers are used for various aspects of your split view controller navigation. For the master view controller, it's going to include a UI navigation controller, which holds a UI table view controller as its root. Now for the detail controller, it provides a basic empty UI view controller. And in the next exercise, you'll be deleting this empty view controller and replacing it programmatically. Before we move on to our exercise, though, I'd like to do a flash quiz. This is an excellent way to test your knowledge. And just a reminder, please pause the video after each question and think about the answer before they're revealed. Question number 1. Which method would you use to replace the master view for an instance of UI split view controller? And that was that first new method we talked about, show view controller. And again, that will replace the master view for a split view controller, or if the calling view controller is contained within a navigation controller, it'll push the new view controller onto the stack. Question number 2. A UI split view controller can push multiple levels of navigation and acts just like a UI navigation controller when used on an iPhone. Is this true or is this false? And this is false. The UI split view controller isn't capable of handling more than 2 levels of navigation. It's just meant for that simple master-detail relationship. If you needed more depth, it would be possible to use a UI navigation controller as the detail view, but this isn't the default behavior, and it would require additional work in your code behind to implement this hybrid approach. It's now time for you to try out master detail navigation on your own. Please return to your downloaded course materials and open up the instructions for exercise number 3. And again, this should take approximately 15 minutes. And I'm going to ask you to pause the video, work through the steps of exercise number 3, and then resume the video when you're ready to review. Please start now. Let's take a look at exercise number 3. So here I've opened the start solution from the part 3 resources folder, and we're looking at the main storyboard. And like before, we see our 4 view controllers for our clock application. So let's jump right into it and implement our master detail navigation. And our first step is to add a split view controller from the toolbox. And we see this is going to take up, well, quite a bit of space. It includes no less than 4 view controllers, and I'm going to do just a little bit of tidying here right away. And let's zoom in and take a look. So on the left, we have our split view controller itself, and its job is to manage 2 child view controllers, one for master and one for detail. Now if we go below, we see an empty view controller, and this can be used as your detail view controller. So based on your selections, you could update content or views here. And that's a great way of doing it. It's not what we'll use. We're going to display the sections of our clock app instead, so we can remove this view controller. Now we also have a navigation controller and a table view controller. And these two together will be responsible for presenting our master UI. They'll present our selections in our master detail navigation. So let's get these set up properly. For our table view controller, let's first give it a useful title. Set this to clock menu. I also want to configure the prototype cell. And we'll set its style to basic because we only need to display 1 row of text. And I want to set its accessory to disclosure indicator. And that's the indicator we use for navigation. And we want to set our reuse identifier. I'll set this to cell ID. And it's very, very important that this matches whatever we use in our code behind. The next thing I want to do is make sure that we set our split view controller as the initial view controller. So it's responsible for presenting our initial UI. So let's move our sourceless segue from our clock view controller to our split view controller. And we're almost ready to wire up our navigation. So what we need now is some logic to present our selections, to manage our navigation. And we'll do that in our table view controller. Now we could create some code behind manually, but to save time, we're going to bring in some existing code, and that's provided in your downloaded course materials. So if you go to your Part 3 resources, open the infrastructure folder, and bring in these two files and add them to your clock project. You should have a menu tableviewcontroller.cs and an associated designer file. Let's get those connected to our table view controller, and then we'll take a look. So select that table view controller under Properties, Identity, and set the class to match. So that should be menu table view controller. Let's open it up and have a look. Now this looks very similar to what we saw in exercise number 1. We've got our table view controller. We're creating a simple string array. These are our labels for our sections, and we're associating a table view source class. That's defined right below. We see that right here. Right away, we see our static string for our cell ID, and that does match what we defined in our storyboard, cell ID. And we see our getCell method is using that from the dequeue reusable cell method, just like we learned in IOS110. Fantastic. So what we want to do now is manage our navigation from the row selected method. And again, to save time, I'm going to copy this code from your lab instructions. Now superficially, this looks much like what we saw for stack navigation, but there is a very important difference. We are creating our switch statement based on the row selected, and we are instantiating our view controllers based on the storyboard ID, just like we did in our stack navigation. But to present these instantiated view controllers, we're using the show detail view controller method. And this, of course, is used to update the detail side of a split view controller. And we see similar code for stopwatch and about. Well, let's try it out. We'll run our application on an iPhone 6 simulator first. And then I want to run it on an iPad and look at the differences. So we see our menu, our 3 entries. This looks very good, but very much like stack navigation. I can click on these entries, and we see that our method, our show detail view controller, is working and presenting our child view controllers. But again, this looks very much like stack navigation. We even have our back button. This is working very well, but it doesn't look much different. But remember, the split view controller on an iPhone collapses down. But on an iPad, things are a little bit different. So we'll start up our iPad 2 simulator, and let's compare to the iPhone. So initially this looks a little bit strange. It appears to be an empty table view, but I can swipe from left to right, and this reveals our menu, and we see our 3 entries, our clock, our stopwatch, our about. And if we click on clock, we see our screen. And we can swipe in again and reveal our menu, and this is the default behavior for our split view controller. And if we rotate to landscape, we see things are a little bit different. And here we've got a little bit of extra space horizontally, and so we get this side-by-side behavior. And we see our menu on the left, our details on the right, and you see this really is a nice way to make better use of the available screen space. But there was something funny with that initial display. We didn't see anything when the app first started. So let's try it on the iPad again, but in landscape. Now here's our app again, and our details are taking up the entire screen. Now when I make a selection, there we see our detail come into place. And the issue here is that we haven't made an initial selection. So the split view controller is not going to display any detail content without being explicitly commanded to do so. So let's add some code to do just that. So let's scroll up to our table view controller source, and we'll do this in view did load. So let's add a new override. And And this code will look similar to what we saw below in our switch statement. We'll instantiate a view controller from the storyboard. Let's make a local variable. We'll call this clockVC. And we'll use our storyboard property on our view controller, and we'll call instantiate view controller. And of course, be very careful. Spelling counts here. Make sure that your string, your ID, matches what you've defined in the storyboard exactly. We want to see clock view controller. And then we'll call show detail view controller, passing in our instantiated VC. And the second property is the sender. We'll just put this. And if we run this again, we see our side-by-side master detail, and we have our detail displayed initially. And of course, you can display any content you like in that detail screen. You can even save it off in settings and restore your state. Now, I do want to show you one last thing. Let's run this on the iPhone 6 now. Now notice what happened. It navigated to our clock screen. So we're no longer presented with that initial menu. It actually goes into, well, one of the detail screens. And so you could branch your logic based on platform if you wanted to. But this is still great behavior, and it gets your user right to the content. I'll leave that up to you as developers to make the decision of how you want to implement this. Now, as a bonus exercise, we again have our split screen. Now, although we're running on an iPhone, and this looks very much like our stack navigation, we're not actually able to push deeper onto the stack. It's not designed that way. Remember, we're actually on our detail screen right now. We're not in the stack navigation, although it looks very much like we are. So again, think of a way to present that additional screen when using master detail relationships. And there is a completed solution showing you one possibility. In this section, we learned how to create a split view controller, both programmatically and through the Xamarin iOS Designer. And the split view controller is an excellent choice when working with larger data sets, and new in iOS 8, with its reactive UI behavior, it can now be used both on the iPhone and the iPad. The final navigation pattern we're going to look at today is page navigation. And page navigation makes use of another container view controller. And we'll learn how to instantiate and populate a page view controller. We'll also talk about the provided template that can be used to quickly set up a page navigation-based project. Now, page navigation is often used when you need to present content in a linear, progressive fashion. And the primary navigation is to step forwards and backwards through the content one page at a time, but it's also common to provide a way to jump to a specific location, especially when you have more than a few pages of content. Now, examples of page navigation include the more obvious applications like ebook and magazine readers, but it's also an excellent choice for implementing wizard-style UIs, in-app help, or really any type of multi-step instructions. We'll use the UI Page View Controller class to enable the user to navigate forwards and backwards through pages of content, and each page is represented by a single child view controller. Navigation is commonly controlled by gestures performed by the user, but it can also be accomplished programmatically. And when navigating between pages, the UI Page View Controller will display transition animations during the change. We can, of course, create instances of a UI Page View Controller class programmatically. And notice it takes a number of constructor arguments. And these are used to control the animation style, the orientation of the navigation, vertical or horizontal, and the spine location. And this controls the location from where the page turns. It could be on the edge of the screen or the center, for examples. Now, these properties must be set when the page view controller is created, and they can't be changed after instantiation. Now, because of this, typically the UI Page View Controller class is used directly, but it can be subclassed if desired. To populate the pages, you'll create a data source class. And this class is responsible for supplying the view controllers which represent each page. And it is called on a page-by-page basis to return the proper view controller as the user navigates. And we assign the data source to the weak data source property on the page view controller. Now the page view data source class must inherit from UI page view controller data source, an aptly named class, and you'll need to override two methods: get next view controller and get previous view controller. And these methods will return the view controller objects that represent the next and previous pages respectively. Now to support gesture-based navigation, you must provide your view controllers using a data source object. Now the data source for a page view controller is responsible for providing the content view controllers, and again, this is on demand. And this means that we can create the child view controllers as they're needed, rather than instantiating every page ahead of time. And this is especially important for larger data sets. Now as Xamarin developers, we can use shortcut delegate properties, and this allows for page retrieval from really any arbitrary class. And you'll need to wire up both the get next view controller and get previous view controller delegates, but this no longer requires you to create a separate data source class. Now when a page view controller first appears, it won't show any content, so you'll need to manually specify the first page. And we do this using the setViewControllers method on the page view controller. Now, if you're using the page curl transition style with a mid-page spine, you need to provide two initial pages, since it's always going to show two pages at a time. Now, optionally, if you know the number of pages that are available, you can provide a quick navigation index to jump between pages. And the page view controller can be configured to display an index, and it creates a UI page control that will be shown at the bottom below the page content. So in order to use this UI page control, there are two UI requirements. First, the transition style of the page view controller must be set to scroll, and the navigation orientation must be horizontal. And both of these properties are again passed into the constructor of the page view controller, and these can't be changed once the page view controller has been created. Now to make the index appear, assuming we've set the correct visual styles, two method overrides are required. And these are overridden on the page view controller data source. First is the get presentation count method, and this simply returns the total number of pages. And we also override the get presentation index method, which returns the index of the initially displayed page. Now make sure that get presented index returns the correct value, and that matches whatever has been set as the initial page. Now we can also create a UI page view controller in the designer, and you'll use the toolbox and search for page view controller, and of course drag it onto your design surface. Now when you drag this onto the design surface into your storyboard, it'll create the view controller, but you need to wire up the child pages programmatically as we discussed earlier. We can't use a segue. Now one last thing I want to mention about page view controllers. The Xamarin iOS templates include a really great page-based app template, and this creates a project with, of course, a UI page view controller, and the default project displays pages showing each month of the year. And this is a fairly comprehensive template, and it's a really great reference or starting point when you're creating a page view controller. And I highly recommend you spend a few minutes reviewing that template. Now before we finish things up today, I want to do one more flash quiz. And again, please remember to pause the video and think about the answers before we move on. Question 1. To assign child pages to a UI page view controller, what can we do? Well, we'll likely do both of these. We'll assign the view controller's property, and this sets the initially displayed view controllers, and then we'll also likely assign a UI page view data source, which will provide the pages as we navigate. Or you can optionally use the delegates, and that's unique to us as Xamarin developers. Question number 2. When using the designer, we can assign child pages to a page view controller using the page view segue. True or false? And that is false. We have to do all of the wiring, all of the instantiation of the child pages programmatically. Although we can create the page view controller using the storyboard, we can't instantiate the navigation from the designer. And that brings us to the end of our video presentation today. Again, my name is Adrian Stevens, and thank you very much for joining me for this presentation of iOS 205. We explored 4 navigation patterns. Remember, if you have any questions, don't hesitate to reach out to a Xamarin University trainer. You're always welcome to email the trainers directly, but you also have access to a dedicated forum as a Xamarin University student. And if you want to go into more detail, you have deeper questions on this topic or any other, don't forget you can always schedule one-on-one time with an instructor using the office sessions. Again, thank you very much, and I hope to see you in a live class very soon.